in I guess the conventional, traditional scientific community, there hasn't been a program of work actually which is focused on trying to explore some of those ideas in nanosystems. And so I thought, and other colleagues in Nottingham thought, it was worth at least trying to get something funded to look at those ideas. Because as I say, at the core, the crux of Drexler's ideas, the single atom chemistry using forces, is a very valid idea. And remarkably, the Funding Council funded it. So this is the system which will be delivered next month into the lab. This is a helium cryostat. The STM is actually buried in here. These long arms are used to move the samples in and out around vacuum without breaking vacuum. And just to give you an idea, again, to put it in context and to put Kurzweil's and Drexler's statements in context, if after 5 years, and there's 4 years left, I get to the point, the group gets to the point, where we can take a carbon surface, a particular carbon diamond surface, 100 surface, and simply form a row of 10 carbon atoms or 10 carbon diamonds on that surface. That would be far beyond the state of the art. So, I know it's a bit, and even then, that's, as you might imagine, an immense experimental challenge. So, I've criticised Drexler a bit. Let's come back and really focus on what the issues are. So we have a great deal of criticism from the nanoscience community regarding this molecular nanotechnology vision. Few scientists, few physicists have actually read Nanosystems. It's an interesting read. It is an interesting read, and you don't pick this book up as someone would have you believe, and you look at it and you go in the first bit, oh, that's just rubbish, and you throw it down. You have to work hard to see where the errors are in that. So I have a lot of time for Drexler, even though I think that he extrapolates rather too much in terms of the power of this technology. So, at the core of MNT is a demonstrably valid idea, computer-controlled, force-driven, single-atom chemistry. So is the fabrication of a universal assembler or a nanofactory just a matter of time? How much time have I got left?
2 minutes.
2 minutes. He says 5, you say 2, which is...
It's the button.
Yeah. Drexler himself describes in detail in nanosystems, for reasons Drexler himself describes in detail, a universal assembler, or we can quibble about whether we actually define a universal assembler, or a set of nanoscale components that can build up and treat any element of the periodic table and move it around, is simply not realizable, and it's for the reasons he himself describes. So I've never been able to understand why we have this. Assemblers will be able to make virtually anything from common materials without labour. Because that actually, if you read the detail in nanosystems, nanosystems contradicts that particular statement. And every element, which is why we come back to surface physics, every element of the Drexlerian nanoarchitecture necessitates a careful consideration of surface-free energy. And that's exactly why he chose hydrogen pulsated diamond. That was really a really good idea. Because if you take silicon, or you take practically any crystal, you cleave it open and you expose that surface under vacuum, the atoms of that surface will reconstruct. They'll move around to get the system to its lowest free energy. And second laws come up time and time again. We've got an interesting diversion on entropic and enthalpic contributions, but I know you're hungry people. So, the key thing is that Drexler was well aware of these fundamental physical constraints that led him to choose hydrogen pulsated diamond as his platform for mechanosynthesis, and then apparently chose to downplay them when stating that virtually anything could be fabricated by a nanofactory. So let me cut to the end. Cut to the key thing. Drexler and many of those who are, again for want of a better term, I hate stating it like this, it sounds almost like a cult. That's not my intention at all. But many of those in the Drexler camp are actually systems engineers or computer systems analysts. And they treat this as an engineering problem. So they black box off the fundamental operations, and then they assume that when we've black boxed off that, that's one level down, and then we can just build on top of that. But the key thing is that what we haven't got a handle on is the fundamental chemistry that actually drives these routines. And we need to develop, keeping with the computer scientist language, that machine language. But even when we develop that machine language for a particular system, it can only work for that particular system. We are never going to get to the point, I hope I don't live to regret this, but we are never going to get to the point where we have a universal assembler or a universal nanofactory. So I've mentioned the debate between Smalley and Drexler in Chemical and Engineering News. I had a really interesting, and in fact this debate led to the grant proposal I mentioned earlier with Chris Phoenix. It gets a little bit acrimonious at times, but if you're interested, it's available from Soft Machines, the Soft Machines blog, which is a blog set up by Richard Jones, University of Sheffield, who used to be the nanotechnology guru for one of the research courses. So, is computer-controlled atom-by-atom chemistry possible? Yes. Have Drexler's ideas been misrepresented in some cases? Yes. Are simple diamonoid mechanosynthesis reactions of the general type laid out by Drexler in nanosystems possible? I think so. It's going to be difficult to justify that grant at the end of 4 years' time if they're not. And does this mean that a nanofactory capable of synthesizing virtually anything molecule by molecule is possible? No. But I'm very much willing to discuss that. Thanks for your attention.
Yeah.
You have the first question.
Microphones, where are they? Where are the fucking microphones? Come on.
You can use this one.
Oh, okay.
Thank you.
Hello there, sir.
So, I would like to ask
No, I'm asking the first question.
Oh,
All right, so thank you so much.
Was that contentious enough?
It was perfect. It was exactly what I was hoping for. I won't go into the virtually anything thing. I have some issues about that, but I would like a slightly simpler question. So you gave a slide about, I guess, 5 minutes ago, which had a reality check.
Yeah.
Go back to that one, please.
Yeah.
And
you asked me how many groups were working on this.
That's it, right. Okay, and you had 2 data points. And I had to step out.
That's not quite 2 data points. Yeah. There's a lot of missing out there, but I'm saying when we go from, I see these as
let me finish my question. I had to miss the early part of your talk, so I don't know whether you said anything specific about your reservations with regard to the Kurzweilian accelerating change concept.
A little bit.
All right. But my feeling is that you can't draw an exponential curve through 2 data points. You need 3.
No, you can draw an exponential.
Now we have 3.
Yeah.
Because the third one is, Philip Moriarty gets a grant from the BBSRC to line up a bunch of atoms. Now, I would like you to speculate on what that really means for the degree of acceleration of change in this.
That's a really good question. So the key focus of that particular grant, the stumbling block for nanoscience and nanotechnology and for the Drexlerian idea is that we've got a tip and we've got a surface. Most of the time we've got very many other techniques that we can apply to this surface. We know what that surface is like. This is the problem. The tip is the problem. And engineering that tip, at the moment, literally what groups do is that scan, don't get atomic resolution, bang, 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 scan, don't get atomic resolution, scratch. Keep scanning until you get atomic resolution. It's almost a brute force approach to actually trying to get atomic resolution. And it's actually getting to the point where you can synthesize and characterize the tips. That's the really difficult thing. If we get to that point at the end of 4 years, in another 4 years' time, then yes, that would be another point, but we're still not anywhere near this exponential development, because that's on one system. And the key thing is it's not transferable.
What I'm saying is, BBSRC doesn't fund things that they don't think are going to work.
Yeah.
They think that you are going to have at least a 50% chance of succeeding in this within 5 years.
I wouldn't say that. So EPSRC, BBS, it's actually an EPSRC rather than a BBSRC. EPSRC continually tell us that what they're looking to fund is adventurous research. Now, you can quibble about that, but we will certainly, the key thing with research as opposed to R&D is that if we find an interesting niche, that we will pursue that niche. We want to get to this point where we can manufacture tips, but the fact that a grant has been awarded does not mean that they have a huge amount of confidence in this kind of capability. There are other questions.
Okay, only one last question. Maybe the gentleman.
So, I would like to ask you, how much do you think we should be concerned about the potentiality of a military arms race in nanotechnology?
I must admit, so briefly covered that type of thing with Chris, and Chris Phoenix at the Centre for Responsible Nanotechnology. And it's not something I want to be drawn into, because I really do not see in terms of where nanotechnology is, we are at the point where we are doing experiments which are literally